When the wreckage first came in, the engineers thought it was just another American plane, another piece of hardware to strip apart, study, and learn from. But as they uncovered the twisted blue fuselage, something about this one felt different. The shape was strange, unnatural almost. Its wings bent like a bird in mid-dive, curling downward before rising again in a sharp, aggressive line. Some of the younger technicians whispered that it looked like it had been built wrong. But the older ones, the ones who had studied aircraft design for years, stood silently, staring at it with the same expression you'd see in a man realizing he was standing before something he could never replicate. They had captured a F4U Corsair, an American marvel that, at the time, seemed almost alien. The Corsair had been forced down after a dogfight somewhere in the Pacific. Its pilot either killed or taken by naval patrols before the Japanese engineers arrived. What mattered most wasn't the man. It was the machine. A machine that looked as though it had been shaped by the wind itself. The aircraft was towed into a hangar at Yokosuka, where Japan's best aviation minds had been gathered to examine captured enemy technology. They had seen P-40s, Wildcats, even a battered P-38 Lightning. Each one had impressed them in some way, but this one didn't look like it came from the same world. The blue paint was thick, rugged, and oddly smooth to the touch, a type of finish they couldn't identify. The rivets were perfectly flush, unlike the crude seams on their own planes. And that wing, that bizarre inverted gull wing, drew everyone's attention. It looked wrong at first glance, inefficient, but the more they studied it, the more it began to make sense. One engineer, a man named Yamashita, traced his hand along the curve and murmured to himself, "This is not a mistake. This is genius." The design allowed the landing gear to be shorter, stronger, and more compact, while keeping the propeller, that massive, monstrous propeller, from striking the ground. It was an elegant solution to a problem Japan's engineers had wrestled with for years: how to combine power with balance. And then came the engine. They removed the cowling, expecting to see a radial engine like their own, maybe a Nakajima or Mitsubishi equivalent, something familiar. But what they found was beyond anything they had ever built. A Pratt & Whitney R2800 double WASP, 18 cylinders of raw power. It was a piece of machinery that looked more like a weapon than an engine. The tolerances were impossibly tight. The wiring was color-coded. Every pipe and fitting seemed deliberate, precise in ways that made Japan's own aircraft engines seem primitive. Even the way the components were arranged suggested an understanding of both efficiency and endurance, as if the Americans had designed it not just for speed, but for survival. The Corsair wasn't just fast, it was built to last. By now, the engineers had gathered around it in reverent silence. No one spoke of copying it, because deep down, they knew they couldn't. Their factories lacked the machinery, the alloys, the manpower. Their nation was at war, struggling just to keep its own air fleet in the sky. And yet, here it was, an American fighter so advanced it might as well have come from the future. Its cockpit instruments were sealed tight against moisture, its canopy crystal clear and thick enough to stop small arms fire. Even the screws and bolts seemed superior. For the first time, these proud engineers, men who had built the Zeros, who had once believed themselves the masters of aerial design, felt something they had never admitted before: defeat. Not in battle, but in innovation. They recorded everything meticulously, sketches, measurements, notes on every detail, but in private, they spoke quietly among themselves. If this is what America builds in numbers, how can we win? They didn't know it yet, but the Corsair was more than just an airplane. It was a message written in steel and horsepower, saying that the age of Japanese air superiority was over. And that was only the beginning of what they were about to learn. For days, the hangar at Yokosuka buzzed like a nest of hornets. The Corsair sat in the center, blue, menacing, and silent, surrounded by tables covered in tools, calipers, paper sketches, and half-finished reports written in tight, meticulous handwriting. It had become more than just a captured plane. It was now the subject of Japan's most secret mechanical autopsy. The order was simple: take it apart, understand it, Todd, and find its weaknesses. But what began as a dissection soon turned into something closer to worship. The team worked slowly, methodically. Every bolt that came loose, every cable that was detached, was documented. They wanted to understand how the Americans thought, how they built something like this. They began with the engine. The monstrous R-2800 sat like a heart torn from a god, its blackened cylinders gleaming under the fluorescent lights. When they turned the propeller hub by hand, it rotated with a smooth, almost liquid resistance, perfectly balanced, no vibration, no play. One of the engineers whispered, This could run for 1,000 hours without failure." They compared it to their own Nakajima sake engines, compact, lightweight, but fragile under stress. The difference was astonishing. Where Japanese engines prized minimal weight and simplicity, the American approach was brute force precision. The Corsair's power plant was overbuilt, armored, over-engineered, dense with parts. Yet every component seemed to belong exactly where it was. The cylinder heads were made from an aluminum alloy they hadn't encountered before, light yet resistant to heat warping. The cooling fins were machined so finely that under light they almost shimmered. And the magnetos, the ignition system, were sealed in protective casings, shielded from moisture and heat. That was when they realized something else. This plane wasn't built for perfection in a laboratory. It was built for chaos, for the salty air of the Pacific, for rough runways, for pilots who could slam the throttle to full power again and again without mercy. The Corsair was a machine that forgave its user. That was something Japanese engineers had never designed for. Their fighters, like the Zero, were masterpieces of lightness and agility, but they were also fragile. They demanded care, precision, and pilots who flew them like swordsmen, graceful and deliberate. But this was a hammer. When they examined the Corsair's propeller, they were stunned again. 4 meters across, thick, heavy, its blades carved to channel more air than any Japanese engine could handle. It wasn't just a propeller, it was an industrial turbine tuned for violence. Then they noticed the gearbox assembly, how it connected the propeller to the engine. The gears were cut with a level of accuracy none of their machine shops could match. Each tooth gleamed like polished glass. They tried measuring them with micrometers, and the tolerances were so tight that one engineer quietly laughed in disbelief. "Even if we had the metal," he said, "we could never make this." As the engineers stripped away more of the Corsair's skin, they found another surprise: armor plating. Behind the pilot's seat, around the fuel tank, even beneath the cockpit floor. It wasn't much by tank standards, but for an aircraft, it was shocking. The Americans had sacrificed speed for protection, something the Japanese designers had almost never done. One of the senior engineers, gray-haired and quiet, ran his hand along the armor plate and said, "They are not afraid to carry weight because they have the engines to lift it." That line stuck with the team. In their pursuit of lightness, Japan had stripped its aircraft down to the bone. The Zero was unmatched in agility, yes, but it could not take a hit. The Corsair, by contrast, could be riddled with bullets and still fly home. Then came the wings, those bizarre, bent wings that had mocked them at first glance. They carefully measured every angle, every rivet, every curve. The more they examined it, the more the design revealed itself as a masterpiece of compromise. The inverted gull shape lowered the landing gear mounts, allowing the propeller to clear the ground without needing absurdly long struts. But that wasn't all. The shape also reduced drag where the wing met the fuselage, smoothing airflow across one of the most turbulent regions of the aircraft. They tested small-scale airflow patterns with smoke and fans, tracing how air moved along the surface. What they saw astonished them. The Corsair's wings didn't just cut through the air, they tamed it. At high speeds, where most planes lost stability, the Corsair stayed smooth and controllable. It wasn't elegant, it was engineered. They examined the control surfaces, the ailerons, flaps, and rudder. Each one was balanced perfectly, reinforced internally with lightweight ribs that prevented warping under high G-forces. Even the hinges were coated in a corrosion-resistant compound they'd never seen before. The cockpit was another revelation. While Japanese aircraft cockpits were simple, almost Spartan, the Corsair's was dense with instruments, switches labeled in English, dials for fuel mixture, manifold pressure, cylinder head temperature, and a massive radio set behind the pilot, far larger and more powerful than anything the Japanese Navy could field at the time. There was even a small heating duct for the pilot's feet, a small luxury that seemed almost absurd during wartime, yet spoke volumes about American design philosophy. This wasn't just a machine of war, it was a machine designed around its pilot. They tested the landing gear too. Retractable, hydraulic, sturdy. It could take the abuse of carrier landings, something Japanese fighters struggled with constantly. The Corsair's landing system was overbuilt, a perfect symbol of American industrial excess turned into function. Weeks passed, and the Corsair slowly disappeared, piece by piece, into the notes, sketches, and blueprints the engineers created. They filled entire ledgers with measurements. They discussed theories late into the night. Yet as much as they studied it, one truth became clearer with every passing day. They could understand it, but they could never build it. The materials, the precision, the sheer scale of the American manufacturing machine, it was out of reach. The engineers began to see something that frightened them more than the Corsair's performance. It wasn't just that America built better machines, it was that America could build millions of them. The Corsair was not the result of a single genius or a small team of artisans. It was the product of an empire of factories, men, women, machines, and resources all working with one purpose. And as the last bolts came off and the Corsair's skeleton lay bare, one engineer summed it up quietly. "We can copy their designs," he said, "but not their nation." By the third month, the Corsair had been reduced to a skeleton. Every piece, from the propeller hub to the tail hook, had been measured, weighed, cataloged, and drawn in exquisite detail. The engineers had fulfilled their orders. They had taken the plane apart, but in doing so, they had also taken apart something else, their confidence. The Corsair had become more than a machine to them. It was a mirror, and what it reflected back was not flattering. The reports that came out of the Yokosuka hangar were thick, filled with technical diagrams, but beneath the data, there was an unspoken truth. Japan's engineering, though ingenious, was falling behind the pace of America's industrial revolution. The engineers didn't want to admit it, not to the military brass, not even to each other, but in quiet conversations over tea, the truth slipped out. "This plane," one of them said, "was not made by men with genius hands. It was made by men with machines we do not have." They compared the Corsair's manufacturing techniques to their own. Where Japan's aircraft were assembled in workshops that still relied heavily on hand-fitting and manual adjustments, the Corsair's components bore the unmistakable marks of mass production, yet with consistency that bordered on artistry. The Americans had mastered something the Japanese still struggled to achieve: interchangeability. The Corsair's parts could be swapped freely between aircraft with minimal adjustment. Each bolt, bracket, and panel fit as if it had been made for one specific plane, and yet it hadn't. It had been made for thousands. To the engineers, this realization was humbling, almost frightening. They had prided themselves on craftsmanship, the fine, careful tuning that made their Zeros light and nimble. But now they were beginning to see that this kind of perfection was no longer enough. The war demanded quantity and reliability, not delicacy. And the Americans, with their factories in full roar, had achieved that balance. They also studied the Corsair's logbooks, records found still intact behind the pilot's seat. The entries revealed something astonishing. The plane had seen combat for nearly a year before being captured. Dozens of missions, long flights over saltwater, carrier landings, dogfights. And yet, aside from bullet holes and crash damage, its structure had held together perfectly. "How is this possible?" one engineer muttered. "Our planes need constant maintenance after every mission." They tested the metal fatigue, the corrosion resistance, and again they were stunned. The Americans had used high-grade alloys, especially in the crankcase and landing gear, that resisted cracking and salt corrosion. When the engineers tried to replicate the mixture in their labs, they couldn't. Their metallurgy was behind. Their machining capacity was behind. Even their electrical insulation, a detail most dismissed, was inferior. The Corsair's wiring used a special synthetic rubber insulation that resisted heat and salt moisture, whereas Japanese planes still used natural rubber that degraded quickly in tropical air. Everywhere they looked, they saw the same message repeated: America had built for the long war. The military officers who visited the hangar wanted practical answers. They asked questions like, how can we make ours faster? Can we copy the wing? Can we use this engine design? But the engineers had no easy answers. They tried to explain that the Corsair wasn't a single design innovation. It was the sum of an entire system of production and technology that Japan did not possess. You could copy the blueprint, yes, but without the factories, the alloys, the tools, and the trained workers, it would remain just paper. And in the corridors of the engineering department, a new kind of silence began to hang in the air. Not of awe anymore, but of resignation. They began to realize something deeply unsettling. They were fighting a war their machines couldn't win. Still, they pressed on, trying to adapt what they could. They studied the inverted gull wing for aerodynamic lessons, hoping to apply the principle to their own designs. They examined the control systems, trying to mimic the balance between power and stability. But every step met a wall. Their aircraft factories were already stretched thin. Aluminum shortages had forced them to use substitutes: steel fittings, wooden components. They didn't have the time or resources to reinvent their designs. Meanwhile, the skies over the Pacific were filling with more Corsairs, newer, faster, stronger. Each one a testament to American manufacturing might. The irony was bitter. Even as they studied the one they'd captured, thousands more were being born across the ocean. One night, after a long day of inspection, one of the younger engineers stayed behind. He sat in the cockpit of the stripped-down Corsair, running his hand along the cold metal of the control stick. The seat was wide, comfortable, designed for a big man in heavy gear. The canopy glass was thick, the switches heavy-duty. Everything about it felt industrial, practical, human-centered. He thought of his own country's pilots, men flying machines that were fast and agile, but offered no protection, no comfort. Men who faced battle in planes that burned if a single bullet hit the fuel tank. And then he whispered quietly, almost to himself, "If I were the pilot, I would want this." In the final report submitted to the Imperial Navy, the engineers included a section titled Observations on American Production Philosophy. It was brief, written cautiously, knowing that criticism of Japan's war effort could be seen as disloyalty. But between the lines, their conclusion was unmistakable. Open quote, "The American system favors quantity without sacrificing durability. They possess vast resources of metal, machinery, and labor. They design not only for combat performance, but for manufacturing ease and maintenance simplicity. Their engineering reflects an understanding that the machine must serve the pilot, not the other way around." Close quote. The report ended with a single haunting sentence. Open quote, "Their machines are made for war, but ours are made for honor." Close quote. It was both an admission and an elegy. In that hangar, surrounded by the disassembled remains of an American fighter, Japan's top engineers realized what their military leaders refused to see. This war could no longer be won through courage or precision craftsmanship alone. It was a war of production, of materials, of endurance, and the Corsair was proof that America had mastered all three. What they didn't know yet was that the Corsair was just one of many symbols of that industrial storm. Soon, even greater machines would come. And when they did, there would be no doubt left. By the time 1945 arrived, the Corsair in Yokosuka was gone, dismantled, its parts studied, its alloys analyzed, its secrets documented in quiet shame. The hangar where Japan's best minds had once gathered was silent now, except for the distant hum of air raid sirens and the tremor of bombs falling somewhere far away. But the memory of that plane, the first time they saw its bent wings gleaming like a bird of steel, stayed with them, because it had not just been a captured aircraft. It had been a revelation, a prophecy of Japan's inevitable reckoning. When the engineers looked to the skies now, they no longer saw the graceful silhouettes of Zeros and Oscars dancing over the Pacific. They saw shapes like the Corsair, massive, fast, terrifyingly durable machines that screamed across the horizon, dropping death from above. The once invincible Japanese air fleet was now struggling to hold the line. Their planes, the pride of early war engineering, were being outflown, outgunned, and outlasted. And for those who had studied the captured Corsair, every encounter in the sky was like déjà vu. They recognized its profile instantly. That gull wing, that deep blue blur that came diving out of the clouds. They had touched one with their own hands, had seen its insides, and they knew exactly what it was capable of. There was a grim respect in that recognition, even fear. The Corsair was not elegant. It did not dance like a Zero. It roared, it clawed through the air, it endured. Its power-to-weight ratio gave it monstrous climb performance, and its armor meant that it could take hits that would have shredded any Japanese aircraft. When the engineers had measured its skin, they'd noted that even the outer panels were thicker, not by much, but enough to make a difference. Now, in the war's final years, they saw what that difference truly meant. Where a Zero would ignite from a single tracer round, the Corsair could limp home, trailing smoke, but alive. Inside Japan's design bureaus, desperation grew. Engineers began scrambling to adapt what little they had learned from that Corsair. Projects like the Kawanishi N1KJ Shiden and the Mitsubishi J2M Raiden reflected pieces of those lessons. Sturdier airframes, better armor, heavier armament, but they were still chained by limitations. Limited resources, limited materials, limited time. The engineers at Yokosuka often whispered that they were building with paper and prayer. They had seen what the Americans could produce, and they knew that no design brilliance could overcome the raw imbalance of industry. For every aircraft Japan produced, America produced 20. For every ton of aluminum Japan mined, America refined 50. For every Corsair destroyed, another rolled off the assembly line, and another and another. It wasn't a fair fight anymore. And yet, the engineers didn't give up, because engineering, for them, wasn't just about victory. It was about pride, about mastery. They poured what they had left into every design, even as the cities burned, even as the factories ran on fumes. Then one day, as the war neared its end, the airfield near Yokosuka filled with an eerie sound. Engines. Dozens of them. The sky above was filled with Corsairs. Not captured ones this time, but combat-ready squadrons flying low, their blue fuselages glinting in the sunlight. The engineers who had once studied one in pieces now saw dozens of them soaring in formation, a living army of the same machine they had dissected with awe and envy. They watched from the ground as they thundered overhead, and though the sight was terrifying, it was also strangely familiar. "This," one of the older engineers said softly, "is the sound of what we could not build." The hangar shook as bombs fell across the airfield. The Corsairs peeled off into attack runs, their engines screaming, their guns flashing. The war had come full circle. The same plane they had studied in silence was now tearing apart the empire that had once captured it. It was not hatred they felt, not even anger. It was something colder and deeper. It was the weight of understanding. In the final days before surrender, as Tokyo smoldered and the nation prepared for the unthinkable, the surviving engineers met one last time. They gathered in a small workshop, their faces tired, their uniforms stained with oil and soot. On the table before them were fragments, bits of aluminum, scorched steel, a cracked propeller tip, and an old sketch of the Corsair's wing. No one spoke for a long while. Then Yamashita, the senior engineer who had first examined the captured Corsair years before, picked up one of the sketches. The paper was yellowed, the ink faded, but the lines were still perfect. The curve of that inverted gull wing, drawn by hand with reverence. He looked at it for a long moment and said, quietly, "Do you remember what we said the first day we saw it?" One of the younger men nodded. "We thought it was broken." Yamashita smiled faintly. "Yes, broken, but it was never broken. It was beyond us." He laid the sketch down. "Do you understand now?" he continued. "This was never about who built the best plane. It was about who built the best world to build planes in." That sentence hung in the air, heavy, final, true. They all knew what he meant. The Corsair wasn't just a triumph of design, it was a triumph of a nation's unity, its industry, its education, its infrastructure, its endless resources. Japan's genius had always been in precision and artistry, but America's genius was in scale. And in modern war, scale had become the ultimate weapon. After the surrender, many of those same engineers would go on to rebuild Japan's future. When peace came, they turned their skills from war machines to something else entirely. Ships, cars, electronics, tools of creation instead of destruction. But they never forgot that first Corsair. They would tell the story to young apprentices decades later, how they once studied a machine that seemed to come from another world. How it humbled them, how it changed the way they saw engineering forever. One of them, long retired, once said in an interview, "When we saw that plane, we realized what true engineering meant. It was not just about performance, it was about purpose." The Americans built their machines for endurance, for reliability, for men who had to come home alive. That philosophy became ours too. It shaped the Japan you see today. And so, in the end, the story of the captured Corsair was not just a story of defeat. It was the story of awakening. Japan's engineers had looked into the heart of another civilization's power, and instead of envy, they found understanding. They learned that greatness in machines comes not from perfection alone, but from compassion, from infrastructure, from the will to build a world where innovation can thrive. The Corsair had been a weapon, but to them, it became a teacher. Voice softens, reflective. When Japan's top engineers first saw the bent-wing Corsair, they thought it was broken. Then they examined its engine and realized it was from another world. And from that moment on, they understood that the war they were fighting was already lost. But the lesson they learned from that machine would help them rebuild an entire nation from the ashes. Because sometimes, you have to lose to understand how to build again. That was the true legacy of the day Japan captured a Corsair.